Titration is one of the most common procedures in chemistry. It can be divided into two tasks: the laboratory itself and of course calculation. Titration is a process of using a known solution to determine the concentration of another solution. This another solution will be the unknown solution. In a common laboratory setup, here you can find your known solution, we call titrant, and here the unknown solution or titrant. What we do here is that we allow a volume of the known substance to be mixed slowly with the unknown substance until endpoint is achieved. What is endpoint? Endpoint is the point at which the acid or base is completely neutralized with the base or acid. But when will we know that endpoint is achieved? Well, indicator like phenolphthalein will be mixed to the unknown substance before mixing it with the titrant. A permanent change of color will indicate the endpoint is achieved. So in summary, performing titration will allow you to identify the volume of the known substance that can neutralize the unknown substance. The unknown substance being unknown in concentration, but the volume would be given. And in performing titration, you will get the volume of the known substance. And these are what we need in our calculations. These are the steps in solving acid and base titration problems. There are 4 steps, but we'll try to discuss one by one while solving a sample problem. Let's try this one. A 25 ml solution of H2SO4 is neutralized by 18 ml of 1 molar NaOH. What is the concentration of the H2SO4 solution? First step is to write the balance equation of the reaction. So we have H2SO4 plus NaOH. These are strong acid and base. And so we have H2O plus salt, which is Na2SO4. I suppose you know how to balance equations already? So your balance chemical equation would look like this. The balance equation tells us that 1 mole of H2SO4 will be neutralized by 2 moles of NaOH, giving us a mole ratio of 1:2. And this ratio will be used later on in the remaining steps. For the second step, we need to find the number of moles of the known solution. To do that, we need to identify all the quantities that are given. Let's start with 25 ml, that's for H2SO4, but we want it to be in liters, so that is 0.025 liters. The molarity of H2SO4 is the one that we're looking for. For NaOH, that would be 18 ml or 0.018 liters. The concentration in terms of molarity is 1 mole per liter. And I want to bring this one out. Molarity is the number of moles per volume in terms of liter. And so, we can say that the number of moles is equal to molarity times the volume liter. So computing for the number of moles, we have 1 mole per liter times 0.018 liters. That will give us 0.018 moles of NaOH. And for our third step, use mole ratio to find the moles of the unknown solution. And as I've said earlier, we can identify the mole ratio from the valence chemical reaction. Therefore, our mole ratio is 1:2. 1 is your acid and 2 is your base. We will multiply the mole ratio and the number of moles of NaOH. So we have 0.018 mole of NaOH multiplied by 1 mole of H2SO4 divided by 2 moles of NaOH. As you notice, I place 1 mole of H2SO4 as the numerator and 2 moles of NaOH as denominator because I'm trying to get rid of NaOH. You can always swap the mole ratio depending on which one you want to solve. So the number of moles for H2SO4 is 0.009 moles. For our last step, solve for the concentration of the unknown solution. And we can do that using the formula for molarity. Molarity is the number of moles over volume. And therefore, molarity is equal to 0.009 mole divided by 0.025 liters. And that will give us 0.36 mole per liter, and that is the concentration of H2SO4. Try to practice by solving this problem. What is the molarity of a solution of H3PO4 if 15 ml is neutralized by 38.5 ml of 0.150 molar NaOH? You can always go back and check the steps. I'll be giving you the reaction below. Try to balance and solve for the concentration of H3PO4. Pause the video and go back after solving and we'll compare our answers. So the balance form is 1, 3, 3, and 1. And if you did your calculation, you should end up with 0.128 mole per liter as the concentration of H3PO4. And that's it for this video. I'll see you again next time. Happy solving!